Hello friends, in my previous video I had completed question number 1, that is multiple choice question. Now in this video I will complete question number 2, and there are 11 problems in this question. Now let us start. First, find the number of sides of a regular polygon if each of its interior angle is 3 pi by 4 radian. Okay, now see this the figure. We know that 1 radian is equals to 180 upon pi degree. Okay, now we'll convert this radian to the degree by multiplying it by 180 upon pi, and after simplification you will get here 135. Okay, and this is the interior angle of the given polygon. Okay, let the number of sides of the regular polygon be n. Measure of an exterior angle is equals to 360 upon n. Okay. Now next, since the sum of the measures of an interior angle and an exterior angle of a polygon is equals to 180, and therefore here we have 135 plus 360 upon n is equals to 180. That is, this is the interior angle and this is the exterior angle. And if we simplify this, that is a 360 degree upon n is equals to 180 degree minus 135. Then you will get here 45, and hence 360 degree upon n is equals to 45 degree, and hence n is equals to 360 upon 45, and that is equals to 8, and hence the value of n is 8, and hence it is a octagon. Then now hence the number of the sides of the polygon is equals to 8. Now next, this is question number 2. Two circles, it's by mistake I had written it's one, but this is the question number 2. Two circles, each of radius 7 centimeter, intersect each other. The distance between their centers is 7 root 2 centimeter. Find the area of the portion common to the two circles. Now the solution, see this figure. These are the two circles whose centers are P and Q. They intersect each other at the point A and B. We want to find out the area of this shaded region. Let P and Q be the centers of the two circles intersect each other at A and B. PA is equals to PB, PA is equals to PB, is equals to QA is equals to QB is equals to 7 centimeter, and PQ is equals to, that is a 7 root 2 centimeter. That is the distance between the centers of these two circles. Since this PA square plus QA square is equals to, that is 7 square plus 7 square, then you will get here 49 plus 49, that's equals to 98, and 98 is a square of 7 root 2, and that is nothing but PQ square. Okay. Therefore, measure of angle PAQ is equals to 90 degree. Now, quadrilateral PAQB is a square, all sides are equal, and one angle is 90, and therefore it is a square. Measure of angle APB, measure of angle APB is equals to measure of angle AQB, that's equals to 90 degree. Okay, we will convert this degree to the radian by multiplying pi upon 180, and hence 90 into pi upon 180 radian, and that's equals to pi by 2 radian. Now we will find out the area of the sector PAB, that is 1 upon 2 r square into theta. This is the formula for the area of sector. Okay, now see this here, 1 upon 2. The radius of the circle is 7, 1 upon 2 7 square into theta, that is the angle is pi by 2, and after simplification you will get here 49 pi by 4 square centimeter. This is the area of the sector PAB. Now next, area of sector AB is equals to again 1 upon 2 r square into theta. Again the same thing is here. That is 1 upon 2 radius of the circle is 7. Therefore 7 square into pi by 2. Then again you will get here 49 pi by 4 square centimeter. This is the area of the sector QAB. Now next, the required area, that is the required this shaded portion is equals to area of the shaded portion is equals to area of the sector PAB, area of the sector this PAB plus area of the sector QAB minus area of the square PAQB. If we subtract the area of the square from the sum of the areas of these two sector, then we will get the required shaded portion, area of the required shaded portion. Okay, now see this here. Area of the sector PAB is a 49 pi by 4 plus what, and the area of the sector QAB is a 49 pi by 4. And what about the area of the square PAQB? It's a square, therefore side square is a 49, and hence their subtraction. If you take the 49 as a common, then in bracket you will get here pi by 4 plus pi by 4 minus 1. Pi by 4 plus pi by 4, then you will get here pi by 2, okay, minus 1. And hence the required area of shaded portion is equals to 49 in bracket pi by 2 minus 1 square centimeter. Okay. Again, you can see this. Okay. And this is the answer. Now, next problem. Triangle PQR is an equilateral triangle with side 18 centimeter. A circle is drawn on segment QR as diameter. Find the length of the arc of the circle within the triangle. Now see this here. PQR is equilateral triangle and the side of this equilateral triangle is 18 centimeter. As it is equilateral triangle, measures of all angles are equal. They are the 60 degree. This is also 60 and this is also 60 degree. Now see this figure. In this figure, if we join OS, then OS is the radius of the circle. OQ is also radius of the circle. If we consider the triangle SQO, this is the isosceles triangle. And in isosceles triangle, as these two sides are equal, therefore their base angles are also equal. But we know that the Q is the angle of this equilateral triangle. The measure of angle Q is 60 degree, and therefore the measure of angle QSO is also 60 degree because they are the angles opposite to congruent sides. Therefore measure of this angle is 60 and measure of this angle is also 60 degree. And if we consider the triangle SOQ, measure of these two angles is 60 degree, 60 degree, and last remaining angles is also 60 degree because the sum of the measures of angles of triangles is 180. Okay, and hence measure of this angle is 60 degree. Similarly, for the triangle OTR, okay, measure of this angle R is 60 degree as it is equilateral triangle, and these two sides are equal, therefore angles opposite to congruent sides are equal, and therefore measure of angle OTR is also 60 degree as measure of these two angles are 60 60, and therefore remaining angle is also 60 degree. Now these are the linear angles and the sum of the measure of the linear angle is 180. This is 60 60 and the remaining must be 60 degree, and hence the measure of angle SOT is 60 degree, and using this we can find out the length of arc ST. We want to find out that. Now see this here. Solution. Let O be the center of the circle drawn on QR as a diameter. Let the circle intersect segment PQ at S and segment PR at T. Then arc ST is intercepted within the triangle. Arc ST is intercepted within the triangle. We want to find out the length of that arc. Okay. Since length of OQ is equals to length of OS, length of OQ is equals to length of OS. Okay. Measure of angle. Therefore, measure of angle OQS is equals to measure of angle OSQ is equals to 60 degree. Therefore, measure of angle SOQ is equals to 60 degree. Just I had explained it. Now, next. Similarly, measure of angle TOR is equals to 60 degree. And hence, measure of angle SOT is equals to 60 degree. Okay. Now, we'll convert this theta in radian by multiplying 60 by pi upon 180, and hence after simplification you will get pi by 3 radian. We want to find out the length of arc ST here. Now QR is equals to 18 centimeter, that is the side of the equilateral triangle. Therefore radius of the circle is equals to 9 centimeter. Length of arc ST is equals to S is equals to R theta. R is 9 and theta is pi by 3, and after simplification you will get here 3 pi centimeter. Okay, and this is the answer. Length of arc ST is equals to 3 pi centimeter. Now next, find the radius of the circle in which a central angle 60 degree intercept an arc of length 37.4 centimeter. Now see this here. The let R be the radius of the circle and S be the length of the arc. S is equals to, we have given the length of the arc, S is equals to 37.4 centimeter, theta is equals to 60 degree, convert to its radian by multiplying pi upon 180, then you will get here pi by 3 radian. Now S is equals to R theta, substitute the value of S, 37.4 is equals to R into pi by 3, and after simplification you will get here R is equals to 3 into 37.4 upon pi. Substitute the value of pi, that is a 22 upon 7, then multiplying reciprocal you will get here 7 upon 22, that is a 3 into 37.4 into 7 upon 22. And next after simplification you will get here the radius of the circle, that is R is equals to 35.7 centimeter. Okay, and this is answer. Now next problem. Now question number 5. A wire of length 10 centimeter is bent so as to form an arc of a circle of radius 4 centimeter. What is the angle subtended at the center in degrees? Okay, let theta radian be the angle subtended by the arc of length S is equals to 10 centimeter at the center of the circle. Okay, now see this here. This is the radius. This is the length of the arc, which is the 10 centimeter. We want to find out this angle theta. Okay, then S is equals to R theta, where R is equals to 4 centimeter. Therefore, here 10 is equals to the value of S. Okay, is 10 is equals to 4 into theta. Therefore, theta is equals to 10 by 4, and that's nothing but 5 by 2 after simplification. 5 by 2 radian. Okay, now convert this radian to the degree. Now multiply 5 by 2 radian by 180 upon pi. Then after simplification you will get here 450 upon pi degree, and hence the angle subtended at the center by this arc is 450 upon pi degree. Okay, now next problem. Two arcs of the same length subtend angles of 65 degree and 110 degree at the centers of the circles. What is the ratio of radii of the two circles? Now the solution, let R1 and R2 be the radii of the two circles whose arcs of same length, capital S, subtend angles of measure 60 degree and 75 degree at the centers of the circles. S is equals to r1 theta 1, where theta 1 is equals to 65 degree. Convert to the radian by multiplying pi upon 180. Then you will get here 13 pi by 36. Okay, and hence s is equals to now r1 into the value of theta in radian, that is the 13 pi by 36. Therefore s is equals to 13 pi into r1 upon 36. This is the expression number 1. Also s is equals to r2 into theta 2. Here theta 2 is 110 degree. Convert to the radian by multiplying pi upon 180. Okay, and after simplification you will get here 11 pi upon 18. Okay, therefore s is equals to r2 into theta, which is in radian, that is 11 pi upon 18, and after simplification here you will get here 11 pi r2 upon 18. This is expression number 2. As the length of these two r's are equal, therefore we will equate these two expression. Okay, therefore 13 pi r1 upon 36 is equals to 11 pi r2 upon 18, and hence after simplification you will get here r2 upon r1 is 22 upon 13. Therefore the ratio of the radii of the circles is equals to 13 as to 22. Now next, the area of a circle is 81 pi square centimeter. Find the length of the arc subtending at an angle of 300 degree at the center, and also the area of corresponding sector. Okay, now using this area of the circle, we'll find out the radius of the circle. Let r be the radius of the circle. Area of the circle is pi r square is equals to 81 pi. Pi get cancelled. R square is equals to 81. Therefore, r is equals to 9 centimeter. Also, theta is equals to 300 degree. Convert to the radian by multiplying pi upon 180. And after simplification, you will get 5 pi by 3 radian. Okay. Now the length of the arc S is equals to r theta. Substitute the value of r is 9 and the theta is 5 pi by 3, and after simplification you will get here S is equals to 15 pi centimeter. Now the area of corresponding sector, the formula is 1 upon 2 r square theta. Substitute the value 1 upon 2, r is 9 square, theta is 5 pi by 3. Okay, and after simplification you will get here 135 pi upon 2 square centimeter. Therefore the length of arc is 15 pi centimeter and area of the sector is 135 pi upon 2 square centimeter. Now next problem. Show that the minute hand of clock gains 5 degree 30 minutes on the hour hand in 1 minute. Okay. The angle subtended by minute hand in 60 minutes is 360. Okay. Therefore the angle subtended by minute hand in 1 minute is a 360 upon 60, that is a 60 degree. Also the angle subtended by hour hand in 12 hours into 60, that is a 720 minutes. Okay, 12 into 60, that is a 720 minutes is equals to 360. Okay, and therefore the angle subtended by our hand in 1 minute means what? 360 upon 720, that is equals to 1 upon 2 degree. Okay, therefore the gain of minute hand on the hour hand in 1 minute is equals to 6 degree minus 1 upon 2 degree, and if we subtract it then you will get here that is a 5 degree and 30 minutes. Okay, now next, a train is running on a circular track of radius 1 kilometer at the rate of 36 kilometer per hour. Find the angle to the nearest minute through which it will turn in 30 seconds. Now the solution. The distance traveled by the train on the circular track in 1 hour that is in 60 minutes is equals to 36 kilometer, because its speed is 36 kilometer per hour. Okay, the distance travel in 30 seconds, that is 1 upon 2 minutes, is equals to 36 upon 60, that is in 1 minute, into again 1 upon 2, because we want to find out the distance travel in 30 seconds means what, half minute. Therefore we are multiplying here 1 upon 2. Then what is the distance covered? That distance covered is a 3 by 10 kilometer. Let theta be the required angle, then s is equals to r theta, where s is the distance travel in 30 seconds. Okay, that is equals to 3 by 10 kilometer, and r is equals to 1 kilometer. Now see this here. This is the distance traveled by the train in half minute, and this is the radius of that track. Okay, therefore 3 by 10 is equals to, we know the value of capital S. S is a 3 by 10 is equals to this radius is 1 kilometer into theta. We want to find out the value of the theta, that is equals to 3 by 10 radian. Now convert this radian to the degree by multiplying 180 upon pi, and you will get here 3 by 10 radian is equals to 3 by 10 into 180 upon pi, and after simplification you will get here 54 upon pi degree. Okay, now substitute the value of pi, that is a 22 upon 7, then multiply in reciprocal. Here you will get here 7 upon 22, and after simplification you will get here 17.80 18 degree. Okay, that is a 17 degree plus 0.18 degree. Now convert this 0.18 degree to the minutes by multiplying here 60, then it will convert into minute. Therefore 17 degree plus 0.18 into 60 minutes. Okay, and after multiplication you will get here 17 degree plus 10.8 minutes. Okay, and that is nothing but 17 degree and 11 minutes approximately. Okay, and hence the required angle is equals to 17 degree and 11 minutes approximately. Now next, in a circle of diameter 40 centimeter, the length of a chord is 20 centimeter. Find the length of minor arc of the chord. Now see this. We want to find out this length of this minor arc. For that we will find out the measure of this angle, that is angle AOB. Okay, now the triangle AMO is a right angle triangle. Here hypotenuse is a 20 and AM is a 10. Therefore measure of angle this theta is equals to 30 degree by 30 60 90 degree theorem. As this is the 30, this must be also 30. Therefore measure of angle AOB is a 60 degree, and we know the radius of this circle, that is a 20, and using this we will find out the measure of this minor arc AB. Now see this here. Let R be the radius of the circle with center at O. R is equals to 40 upon 2, that is a 20 centimeter. Let AB be the chord of the circle where length of chord, that is equals to 20 centimeter. Length of chord AB is equals to 20 centimeter. Let OM be the perpendicular drawn from the center O to the chord AB. Then M is the midpoint of AB. M is the midpoint of AB. Length of AM is equals to 1 upon 2 into AB, that is a 20 upon 2, that is equals to 10 centimeter. This is the length of AM. Now measure of angle AOM, measure of angle AOM is equals to theta 1 in the right angle triangle OMA. Sine of theta 1 is equals to AM upon OA, that is a hypotenuse. 10 upon 20 is equals to 1 upon 2. Okay. Now the next, sine of theta 1 is equals to sine 30. Therefore theta 1 is equals to 30 degree. Therefore measure of angle AOB B, measure of angle AOB is equals to theta is equals to 2 into measure of angle AOM, and that is a 2 theta 1. That is nothing but the theta. The value of the theta 1 is a 30. 2 into 30, then you will get here 60 degree. Convert to the radian by multiplying pi upon 180. Then after simplification, you will get here pi by 3 radian. Now the length of the minor arc of chord AB is equals to S is equals to r theta. Substitute the value of r, that is the radius of the circle 20, and theta pi by 3, and after simplification you will get here 20 pi by 3 centimeter. This is the length of minor arc of chord AB. Okay, and hence the answer, the length of minor arc of chord AB is equals to 20 pi by 3 centimeter. Now the next problem, the angles of quadrilateral are in AP and the greatest angle is double the least. Find the angles of the quadrilateral in radian. Now solution. The angles of the quadrilateral be a minus 3d, a minus d, a plus d, a plus 3d in degrees. Okay. Since sum of all the angles of the quadrilateral is 360 degree, therefore a minus 3d plus a minus d plus a plus d plus a plus 3d is equals to 360. Okay. Therefore, here minus 3d and plus 3d get cancelled, minus d and plus d get cancelled. If we add all the a's, then you will get here 4a is equals to 360, and after simplification you will get here a is equals to 90 degree. Also, we have given the relation. What is that? The greatest angle is double the least. Okay, and therefore what is the greatest angle? A plus 3d, and which is the least? A minus 3d, and therefore here a plus 3d is equals to 2 in bracket a minus 3d, and after simplification here you will get here a plus 3d is equals to 2a minus 6d, and here 9d is equals to a is equals to 90 degree. Here 3d plus 6d, that is a 9d, and 2a minus a, you will get here a, but we know the value of here a, that is equals to 90 degree, and as 9d is equals to 90 degree, therefore d is equals to 90 degree upon 9, and hence d is equals to 10 degree. Now we know the value of a and d. We will find out all the angles of this quadrilateral. The angles of quadrilaterals are, first a minus 3d, that the value of a is a 90 degree, minus 3 into d is a 10 degree, that is a 90 minus 30, you will get here 60 degree. Next a minus d, 90 degree minus 10 degree, 80 degree. A plus d, that is a 90 degree plus 10 degree, 100 degree. A plus 3d, 90 degree plus 3 into 10 degree, that is equals to 120 degree. Okay, and now we will convert this degree to the radian by multiplying pi upon 180. Now here 60 degree is equals to 60 into pi upon 180 radian, and after simplification it is a pi by 3 radian. For 80 degree it is a, again the same thing, 4 pi by 9 radian. For 100 degree it is a 5 pi by 9 radian, and for 120 it is a 2 pi by 3 radian. And in this way we have completed this miscellaneous exercise. Now we will see in the next video. Till then, goodbye.